Okay, good afternoon, all of you. I'm audible.
Yes, sir.
Yes, sir.
Okay, guys, today we have another lecture. So thank you. So be active. Okay. So in next week there will be the ISC. That's why we have to cover the slab. Okay. So now we have to start the lecture. Okay, put the message on your group so you can join the lecture. Okay. Now. In the last lecture, we have seen the principle of feedback amplifier, right? So now, in this lecture, we have to cover the concept of feedback amplifier, and next is we have to revise whatever we have covered. And the classification of amplifier, you all are aware. Now we have to see here the concept of feedback amplifier. Today's lecture. So put the message on your group. You can join the. So now we will take a much more time. So write down all of you the problem. Okay. So all of you write down question number and based on the problem. So we see the 2 or 3 problems, or 2 problems. Then we see the theoretical. Okay, write down all of you. The voltage gain of amplifier. The voltage gain of amplifier. The voltage gain of amplifier without feedback is 500. Without feedback is 500. If beta is equal to 0.3, if beta is equal to 0.3, then determine the voltage gain of negative feedback amplifier. The voltage gain of negative feedback amplifier. Okay, have you completed, all of you? Have you written that problem?
Yes,
Yes,
sir.
sir.
Yes, sir.
Can anybody read that what you have written?
Yes, sir.
Read it.
The voltage gain of amplifier without feedback is 500. If beta is equal to 0.3, then determine the voltage gain of negative feedback amplifier.
Very good, very good. So what is given here?
A and beta.
AV and beta. Okay, I will write here the given data. Given data is given data. First one is AV. What is AV value? 500. What is the beta?
0.3.
0.3.
0.3. Very good. So now, what they have asked, what we have to find out here? What we have to find out here? AVF. What is the formula of AVF for a negative feedback amplifier? Yes, yes, we have seen. Sure.
AV upon 1 plus AVB.
Okay, AV upon AV upon 1. कौन सा है शेरियो?
1 plus ABB.
1 plus beta
into beta.
AV
it is plus or minus.
plus
Plus.
When we are or when the examiner asks to find out the negative feedback, then here the sign is
Plus positive.
plus. When the examiner asks to find out the positive feedback, the formula is here, the value is negative. Remember. Now, put that value and find out the answer. Find out the value. Yes. All of you find out, put the directly value. What is the value? AV किती आहे? 500 upon 1 plus what is the beta value? 0.3 into 500. Calculate it and tell me the value of AV.
3.311.
3.311.
3.311.
Very good. So this is the okay. Okay, right. Now okay. So what we have to calculate here? Just a minute. Just a minute. Okay, so next problem. I will give you the homework. Sorry. I've written this, all of you.
Yes.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Anyone has any doubt?
No, sir.
Okay. So write down the question number 2 and find out the. Okay. So the question number 2, the voltage gain of amplifier. Write down the voltage gain of amplifier. All of you write down the voltage gain of amplifier without feedback is 18. Sorry, without feedback is 100. Without feedback is 100. Without feedback is 100. The voltage gain with voltage gain with the voltage gain with negative feedback is 20. The voltage gain with negative feedback is 20. 20. Full stop. Determine the beta in percent. Beta in percent. Okay. So find out what is the given here. Can anybody?
AV and AVF.
AV and AVF is given.
AV.
So what they are asked here?
Beta.
Okay, beta, but we have negative feedback. We are asking about negative feedback. So you all are know that. We know that. What we know? We know that AVF is equal to AV upon
1 plus beta AV.
here. We have to calculate here
Beta.
this equation. We are in this equation. How to rearrange? Huh? Yes. कसं rearrange करावं लागेल?
AVF into 1 plus beta AV
Okay, rearrange
equal
that.
to AV.
AVF into 1 plus beta AV is equal to AV, right? So now
Yes.
put that value. AV is 21 plus beta. What beta we have to calculate, right? So beta kept it as it is into 100 is equal to 100, right? So multiply this 20 plus 20 plus काय येतो बरं
2000 beta.
2000 beta
Beta.
is equal to 100. So otherwise you can shift this towards this directly. Okay, कुठलं करता शिफ्ट करता
Yes, sir.
शिफ्ट करून काढा आन्सर फाइंड आउट करा. It is possible to find out, all of you. Okay, so you get here
0.00.
it is equal to
0.4.
0.4. We have to find out into percentage, right? So otherwise I will tell you simple. So 1 plus 100 beta is equal to 100 divided by 20. You get so you get 1 plus 100 beta is equal to 5, right? So this 5 is shift toward this side. So 100 beta is equal to 5 minus 1. You get beta is equal to 4 by 100. Yes, बराबर है.
Yes.
So you have to find out beta into percentage. Percentage means 4 divided by 100 into 100. 100 get cancel. Beta is equal to
4.
समझला का? If anyone has any doubt for this problem, है का?
No doubt.
Okay. If anybody has any doubt, so you can ask. Write down. Okay, shall I erase this? Yes.
Yes, sir.
Okay. I will give you one homework. Solid. All of you. Okay, write down the homework. All of you write down the homework. All of you write down. Question number 3. This is for homework. Okay, all of you find out. Solve करू शकता? Homework दिल्यावर मी.
Yes, sir.
Yes, sir.
Okay, write down. The voltage gain of amplifier. The voltage gain of amplifier. Am I clear? Audible to you, or some disturbance is there?
Yes, sir. Disturbance is there.
Just a minute. We wait for 5 minutes.
क्वेश्चन लिहा सर व्हाइट बोर्ड वर.
Question लिहितो तोपर्यंत मी. Okay. Okay, write down this problem and what they ask here. You have to find out
Beta in percentage.
beta in the percentage.
Percent.
Just we have solved that problem same, but the value of feedback gain is different. Okay, so just determine this. Okay, so this is homework. All of you solve it, and I will check tomorrow this. Okay, so now just next concept is the feedback amplifier. Okay, so for that, okay, so now we move toward the next problem. So try to, we have to go for the next concept, the feedback amplifier. Okay, so shall I erase this?
Yes, sir.
Okay, so now move for the next. Okay, just okay, recall all this concept, and we continue within a minute. So please revise whatever we have seen. Hmm? Okay, write down this diagram, the concept of feedback amplifier. Okay, guys, write down this diagram, draw this, then you start the explanation related to this. Write down this diagram. Okay, write down. If anybody has any doubt related to this, if any block is not getting, then let me know. All of you, draw it. Okay, so draw it. Now, what is the unit name? Their point number is concept of feedback amplifier. Okay, so first block is source signal. All of you draw this. Second block is mixer. Someone from last lecture, someone asked where the mixer, right? Who asked that question?
Me. Missile.
Okay, Misa. Now explain it up to here. Okay. So write down this. Second block is mixer. Third block is amplifier, that is AV. Okay. Fourth block is sampling network, and the bottom block is feedback network. That is beta is equal to VF upon V0. Right. So this is figure number A, the basic block diagram of feedback amplifier. Okay. So now we explain this block diagram in detail. Okay. So first we here explain the series mixer. Okay. So here the mixer block is connected in series with the or source register, and feedback network is connected with the series. Okay, so that block comes under in a mixer block. Okay, so and next shunt, if they ask in shunt connection, so in a mixer block the inside of that connected is connected in a series or connected in a shunt. It is the based on types of feedback connection. Okay, so it may be shunt, it may be series. Okay, so we see in detail one by one. Okay, so just we consider if I want to connect this mixer block in a series with the source, the connection diagram is like this. So this is the amplifier block. Okay, my screen is visible, all of you. This is the amplifier output. Okay, so amplifier block. Here the RES is there, right? There is source register. Source, this block is connected like this. So this is the feedback here. The feedback network, that is beta. Feedback network, that is beta. Okay. So the connection is like so. This block, this is the block is mixer. Okay. This block is a mixer block. Okay. So now this connection is connected in a series or shunt. मिक्सरचा कनेक्शन कसा आहे बरं?
Series.
Series, very good. Then series. Okay, so now if I want to connect this network in shunt, so how I connect here? I'll have to draw this diagram. ड्रॉ करा डायग्राम. This connection diagram is in कसे आहे बरं हे कनेक्शन. त्याचं मिक्सर कसं येईल. This is the mixer block. This connection is connected in parallel or shunt. Shunt mixer. Okay. So now this is the mixer block. Okay. समजलं का शंट काय असते आणि सिरीज काय असते. सिरीज कनेक्शन कसं आहे, शंट कनेक्शन कसं आहे समजलंय का, हो किंवा नाही.
Yes, sir.
Yes, sir.
All of you. Shall we move ahead for in details of this block diagram? Huh? Or if anybody has any doubt. अरे बोला काहीतरी. माझा आवाज येतोय का.
रेजिस्टर काय आहे सर.
Yes, sir.
सर
तो आरएस आहे, सोर्स रजिस्टर.
का कनेक्ट केलाय सर तो.
ओके. आपण व्होल्टेज फीडबॅक रजिस्टर किंवा व्होल्टेज अँप्लिफायर बघितला.
येस सर.
त्यामध्ये सोर्स रजिस्टर होता. कॉमन इमिटर अँप्लिफायर किंवा कॉमन बेस अँप्लिफायर किंवा कॉमन कलेक्टर अँप्लिफायर त्यामध्ये होता का सोर्स रजिस्टर.
येस सर.
बघितला होता तिथं काय फंक्शन होतं सोर्स रजिस्टरचं, आठवते का काही. सविस्कार. शुभम, वैशाली, कोणाला आठवतंय का. This is the internal resistors. Yes. So its limit the fluctuation. If the input is fluctuated, at that time the source register is work. Okay. So there is no need to mention. It is an inbuilt register. Okay. Source register. So what is the function of source register here?
Constant current.
If the overloading is comes from outside of the circuit, okay, suddenly high voltage comes from the MSCB. At that time, it protect this circuit. Okay.
Yes sir.
Now, so this is the connection. Okay. So now the figure. Have you drawn this figure number B and C? All of you.
Yes, sir.
Okay, so shall I erase this? Now again I will give the diagram. All diagram you have to draw. Okay, and then we see the in detail theory related to. Now the mixer block is clear now, all of you. Mixer connection कसा असते समजले ना सगळ्यांना.
Yes, sir.
Okay, so now we see another point, that is जो की तुमचा सॅम्पलिंग नेटवर्क आहे. कसं कनेक्शन असायला पाहिजे ते आपण बघू. Here now draw the figure number D. All of you draw with me. So this is the amplifier circuit, right? The amplifier circuit. All of you draw with me. Amplifier. Now the connection diagram. The sampling is this amplifier connection is connected to the sampling block, right? This is REL. the feedback network. Okay. So now this hidden here, the hidden connection diagram is there, right? This hidden connection diagram is here one block is connected. That is the sampling block, right? So in a current and voltage, in a current, just a minute. Okay, so this circuit is connected. This the sampler circuit is connected in a
Series.
series. So if the feedback is always connected in a series, that's that diagram known as number D as the current sampling. Okay, current sampling. करंट आपण कधी अक्रॉस मेजर करतो का? हा
हो सर.
नाही. त्यामुळे आपण याला काय म्हणायचं आहे? तर तुम्हाला म्हणलं की बाबा हे व्होल्टेज सर्किट आहे. सो इट इज व्होल्टेज सर्किट? नो. नेवर. व्होल्टेज इज मेजर्ड across the any element. करंट कसा मेजर करतोय आपण? ते सर्किट
In series.
in series, right? So that's why this is the current sampling. Okay. So now if I want to connect this circuit as a voltage sampling, what is the changes here? Draw this diagram. Okay, that first of all draw this diagram, then we see the voltage sampling. We have to finish it here today. That's why write down fast. Otherwise take a screenshot. कुठलं करता? मी डायग्राम काढतो त्यावेळेस माझ्या सोबतच डायग्राम काढत जा. Have you drawn this diagram? All of you.
Yes sir.
Yes, sir.
Okay. Shubham is there? Shubham? Kamli. Shubham is there?
Don't know sir.
Okay. I think he's not there. He's left. Okay. So Rushali, shall you have you draw this diagram? Rushali,
Yes, sir.
have you drawn the diagram?
Sir, तुमचा आवाज
I
येत
have taken screenshot.
माझा आवाज येत नाही का? Yes.
येतोय. Yes sir. येतोय.
शरीव कोण आहे ते? हा ऋषाली म्हणतात की आवाज येत नाही. ऋषाली तुम्हाला आवाज येत नाही का माझा?
नाही. Yes, sir.
येतोय का नाही?
सर खूप कमी येते तुमचा आवाज.
माझा आवाज खूप कमी येतोय.
सर मे बी नेटवर्क इश्यू मुळे येत नसेल व्यवस्थित.
Okay, okay. Now, have you drawn the diagram?
Yes, sir.
Yes, sir.
Rushali, have you drawn this? Rushali Guru, I am asking to you. तुम्हाला माझा आवाज येत नाही का क्लिअर?
Yes, sir.
येतोय सर.
रुशालीलाच कसं काय जात नाही? हे काहीच बोलत नाहीत.
सर येतोय आता.
ड्रॉ केलंय का डायग्राम मग? रुशाली मी तुम्हाला विचारतो.
नाही सर, करते मी सध्या.
मी तुम्हाला पहिले सगळ्यांना सांगितलं होतं की मी जेव्हा डायग्राम ड्रॉ करतोय तेव्हा डायग्राम ड्रॉ करून सांगितलं होतं का नाही? So why you are not drawing?
Sir, I am drawing now.
Draw it fast.
Yes, sir.
शिंदे, वैष्णवी शिंदे. Vaishnavi Shinde is there?
Yes, sir.
Have you drawn this diagram?
नो सर,
वाय?
ड्रॉ करतेस.
म्हणजे मी म्हणल्याशिवाय ड्रॉ करायचं नाही ठरवलं का लोकांनी तुम्ही?
नाही केले सर.
प्रीती तावशे, प्रीती तावशे आहेत का? Have you drawn the diagram? Okay, so now good. Now next concept. If I want to measure the voltage or I want to connect the voltage sampling, then I just modify here. You have to draw, or otherwise shall I draw again?
No, sir.
Just I will modify here. मी मॉडिफाय केलं की तुम्ही ड्रॉच करणार नाही, त्यालाच मॉडिफाय करता तुम्ही.
नाही सर, आम्ही ड्रॉ करतो.
Okay, so draw here. If I want to measure the voltage, then take this from here, connect this and like this, right? So instead of current, write down here as a voltage sampling. Okay, so figure number E. Draw this fast. We have to finish off this working also. Okay, so in the signal or in this diagram, block diagram, the output signal is sampled by suitable sampling network, right? So in this sampling, okay. Okay. The sampling network, the output of feedback network which has fractional of output signal is combined with the external source signal that it is given into the input amplifier. कसं कुठं कनेक्ट केलंय बघा ते. ओके, या सिंपल या डायग्राम फीडबॅक सर्किटचा आउटपुट हे एक्सटर्नल सोर्स सोबत कनेक्ट केलंय. कशा थ्रू केलंय? मिक्सर ब्लॉक वापरलाय का?
येस सर.
त्यामध्ये दोन कनेक्शनच्या टाइप द्यायच्या, एक शंट मिक्सर अँड series mixer, right? That is block diagram B and C, right? Open your
Yes,
notebook
sir.
and see the diagram number B and diagram number C. Okay, so now the questions comes under in a what is meant by source signal. This block, source signal block. Where is the source signal block? This, right? The source signal block is the block, the signal, either signal voltage versus series with the voltage versus with the series in the source register, that is RES, right? So, or the current signal, it may be voltage or it may be current in shunt with RES. जर voltage असेल तर कसा असणार आहे आपला सर्किट डायग्राम मिक्सर मध्ये? RES रजिस्टर सोबत कसा कनेक्ट केला बाळांनो? बघा डायग्राम.
Output linked with the above terminal.
राईट. नाव आता हे झालं तुमचा सोर्स आणि मिक्सर. सोर्सचं काम काय आहे? एक्सटर्नल व्होल्टेज आपण काय केलंय? अप्लाय केलं, इनपुट दिलंय अँप्लिफायरला ब्लॉक. पण ते कशा थ्रू दिलं? मिक्सर थ्रू. ओके, मिक्सर थ्रूचं मिक्सरचं कनेक्शनची प्रॉब्लेम काय आहे? कनेक्शन प्रोबॅबिलिटी काय आहे त्याची? either series or shunt, depends upon the कशावर डिपेंड आहे ते? कनेक्शन, कनेक्टिव्हिटी. ओके, Now,
Yes, sir.
next important block, that is the feedback network. Okay, the function of feedback network is to return some part of the output energy from output signal to the input. राईट, बरोबर आहे का? आता एक्झॅक्ट मिनिंग घेऊ नका इथं, सगळ्याला सगळंच देतंय का आउटपुट सगळं देत. ओके, आपण जर सिरीज मधनं घेतलं किंवा शंट मधनं घेतलं, एखादा वायर पॉवर सप्लाय चाललाय, आपण एखादा वायर कनेक्ट केला त्याला सिरीज मध्ये, तर काय होतंय बरं? तो पण लाईट लागतो.
Yes, sir. Energy loss.
थोडं थोडं कमी लागेल दोन्ही पण, राईट.
Yes, sir.
Same असते. ओके, so the input signal, some part of the output signal is given to the input to the voltage or amplifier or current amplifier. Okay, so that part of signal is given through the feedback, that is the VF is given, right? So you all are known what is the VF is equal to. VF is equal to काय आहे बाळांनो?
Beta V0.
F is equal to beta V0, right? Okay. Now another circuit, that is the sampling block. आता हे ब्लॉक माहित झाला आपल्याला, हा ब्लॉक माहित झाला, हा पण माहित झाला. आता काय आहे सॅम्पलिंग ब्लॉकचं फंक्शन काय आहे? सॅम्पलिंग नेटवर्क आर two types of network, that is voltage sampling and
Current sampling.
current sampling. Okay, so now for voltage sampling, the feedback network is connected into the shunt with कशाच्या शंट मध्ये कनेक्ट केला आपण फीडबॅक?
Current
RL.
sampling.
आय एम आस्किंग अबाउट. सो बघा, मी काय म्हणतोय, व्होल्टेज सॅम्पलिंग जे नेटवर्क आहे
Yes, sir.
ते कसं कनेक्ट केलं? शंट मध्ये. कशाच्या?
Feedback.
नाही, फीडबॅक सर्किटच आहे आपलं. आपण व्होल्टेज सॅम्पलिंग फीडबॅक ब्लॉक कन्सिडर केला, पण तो शंट मध्ये कनेक्ट आहे. कशाच्या?
RL.
RL किंवा आउटपुट सिग्नलच्या काय केलेला हा शंट मध्ये कनेक्टेड आहे का?
Yes.
Okay, if we consider this as a current sampling, the current sampling network of feedback is connected with the, कसा कनेक्ट केले त्याला? With the
Series.
series. का? The current you have to always measure in a series with that circuit, right? If I want to measure the voltage of any circuit, then I want to connect that voltage source or whatever we have to measure in a parallel, right? So now clear. Now the voltage network are two types of network. First one is voltage sampling and second one is a current sampling, okay, with the output signal. Okay, now for voltage sampling, the feedback network is connected in a shunt with the output signal. Okay, now for current sampling, the feedback network is connected in a series with the output network. Okay,
Yes.
आता काय करायचं आपल्याला? करंट आणि व्होल्टेज. करंट मेजर करताना फीडबॅक सर्किट कुठं कनेक्ट करायचं आपल्याला? इन सिरीज. आणि व्होल्टेज जर घ्यायचं असलं, व्होल्टेज सॅम्पलिंग घ्यायची असेल तर काय करावं लागेल आपल्याला?
Shunt.
शंट मध्ये. Okay, now another important point related to the network block. Network block साठी important point आहे. There are two types of mixing, right? That is a series and shunt mix. In series mixing, the feedback signal is connected in series with the input signal. बरोबर आहे? हे इनपुट सोबत कनेक्ट करतोय आपण.
Yes, sir.
Right. Now, in shunt mixing feedback, the connected signal is in shunt with a input signal. इथं कशासाठी आउटपुट सिग्नल मध्ये करतो तो आणि इथं कशासाठी इनपुट. आता एक्झॅक्ट अपोजिट लक्षात कसं ठेवायचं, सॅम्पलिंग आणि मिक्सर. मिक्सिंग हे कशा सोबत कनेक्ट आहे, इनपुट सिग्नल आणि सॅम्पलिंग हे कशासोबत कनेक्ट आहे,
Output.
Output.
okay. Now आता the question related to the okay, for a current sampling the feedback network is connected dash dash with the output,
Feedback with output.
but how,
Series.
In series.
series. Very good, series. Okay, now the question again, in a shunt dash dash feedback is connected in shunt with the input signal. कशाच्या कुठला ब्लॉक आहे हा,
Mixer.
right, very good. Now it is clear now up to now this.
Yes, sir.
The one block is remaining. Which block one? That is a amplifier. Okay. So it is the transfer ratio or transfer gain of amplifier. Okay. Basic amplifier you all are known. Yes or no?
Yes, sir.
Yes, sir.
Now the ratio of the amplifier is the ratio of output signal of amplifier to the input signal of, or input signal is given. Simply बघा आता मी डायग्राम ड्रॉ करतोय. Shall I erase this part? Okay. Now related to this, just very important point now, last point of this diagram. This diagram is very important. If you didn't understand this, so you didn't get this whole chapter. Okay. हा एक amplifierचा ब्लॉक आहे. ओके, amplifierचा ब्लॉक आहे. तर याच्यात मला काय सांगितलंय, कशा कशात आहेत दोन, एक इनपुट सिग्नल आहे, एक हे काय आहे, इनपुट सिग्नल आहे आउटपुट. ओके, हा आहे amplifier. काय आपण काय म्हणतो त्याला, ट्रान्सफर रेशिओ किंवा ट्रान्सफर अँप्लिफिकेशन. याच्यावरनं जर तुम्हाला गेन काढायचा असेल तर काय करतात तुम्ही, हे कॅल्क्युलेट करायचं. व्हॉट द इक्वेशन,
V naught upon I. Output voltage upon input.
output voltage upon
Input voltage.
so output signal of amplifier upon input signal of
Amplifier.
right. याच्यात दोन तीन कंडिशन येतात तुमच्या. If the input signal to the amplifier is input voltage Vi and output of amplifier signal is output of voltage V0, then the transfer gain is, कसा येतो, ट्रान्सफर मी काय म्हणतो, फक्त व्होल्टेज बोलतोय. फर्स्ट it is related to the only voltage, right? So if I consider V equal to V0 upon Vi, then it is called as a EV. बरोबर आहे.
Yes, sir.
काय केलंय, इनपुट पण व्होल्टेज आहे आणि आउटपुट पण
Voltage.
voltage आहे. So that ratio is, it is known as voltage gain of
Amplifier.
amplifier. Okay. Now, shall I erase this all?
Yes, sir.
Now the second point, it is very important. Huh? The second point. Okay. So A is equal to V0 upon I in. काय बघा आता याच्यात काय, if the input signal of the amplifier is current, that is I, okay, and output signal of amplifier is voltage, that is V0. Then the transfer gain is can call as the R. So this is called as trans resistance. Trans resistance, okay, of amplifier. तुम्हाला 4 पॅरामीटर महत्वाचे आहेत. फर्स्ट काय होता? व्होल्टेज गेन. सेकंड काय आहे? ट्रान्स रेजिस्टन्स. आणि थर्ड काय आहे? थर्ड इज okay, so AV A is equal to I0 upon P किंवा I0 upon PI. काय केलं आता इथे सांगा बरं स्टेटमेंट काय होते याचं? काय स्टेटमेंट होते? If the input signal to the amplifier is voltage and output of signal of amplifier is current, right? So then that transfer function is called as transconductance. समजला का पॉइंट? बघा तुम्ही इनपुट काय करायला इथे अप्लाय काय करताय?
व्होल्टेज.
आणि आउटपुट काय कन्सिडर करताय?
करंट.
मग आता सिंपल डेफिनेशन आहे. द रेशियो ऑफ इनपुट व्होल्टेज टू द आउटपुट करंट, that is known as
Trans resistance of amplifier.
Remember what I am?
Transconductance.
Transconductance. Remember the sentence. The input is voltage and output is
Current.
current. That is known as
Transconductance.
transconductance. Okay. Now the input is current and output is voltage. That is known as
Trans resistance.
trans resistance. Okay. Now the last term is the remaining. That is important. A is equal to V I0 upon II. This is all are known. I बरं आहे
करंट गेन.
ओके. आता समजलं. तर 4 पॉइंट लक्षात ठेवा. एक व्होल्टेज गेन, दुसरा करंट गेन. तिसरा पॅरामीटर काय आहे? ट्रान्स रेजिस्टन्स. चौथा काय आहे? ट्रान्सकंडक्टन्स. Okay. So up till this, anyone has any doubt?
No sir.
If anybody has any doubt, so you can ask. And in our next lecture, we see the different types of feedback connection. That is voltage series feedback connection, voltage shunt feedback connection, current series feedback connection, current shunt feedback connection. Okay, we see this part in a next lecture. Okay, so whatever we have covered up till now, if anybody has any doubt, you can ask me. We wait for 2 minutes. If anybody has any doubt, you can ask.
Hello sir.
Yes.
Sir, in a mixer and in a sampling, different. What is the difference there?
Okay. In a mixer, you are connecting or you are adding. काय ऍड करतो आपण? इनपुट सिग्नल आणि फीडबॅकचं आउटपुट सिग्नल, आणि त्या दोघांचं कॉम्बिनेशन करून काय केलंय आपण? ट्रान्सफॉर्मर किंवा अम्प्लिफायरला दिलं. बरोबर आहे?
Yes sir.
मग आता त्याच्यात असं काय ठरलं होतं का की सिरीज मध्येच पाहिजे किंवा शंट मध्ये पाहिजे? त्याच्यावरून फक्त त्याचे 2 टाईप केले होते. बरोबर आहे? सर नो.
Yes,
मग
sir.
ते व्होल्टेज असो का करंट असो, बरोबर आहे?
Yes, sir.
पण सॅम्पलिंग मध्ये काय केलं होतं आपण? आउटपुट हे शंट मध्ये घेतलं. शंट मध्ये घेतलं तर तो काय आहे?
Voltage.
आणि जर सिरीज मध्ये घेतलं तर तो काय आहे?
Current.
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 पण याचं इनपुट जेव्हा देतो आपण मिक्सर थ्रू, असं काही आहे का? मिक्सर काय करते? सिम्पली ऍड करते ते दोन कनेक्ट. Addition of two signal, simple in a one line. What is in the mixer? It is a addition of two signal. Okay. आता समजलं का आविष्कार?
Means, yes, sir. Means if we trying to take current, then in sampling we need to do the circuit like a series.
हा, राईट.
And
कारण
if we
आपण काय करतोय त्याच्यातून आपल्याला किती आउटपुट भेटलं ते आपल्याला काढायचं आहे, बरोबर आहे का नाही? आणि
Yes.
त्याचा काहीतरी पार्ट आपल्याला काय करायचा आहे? इनपुट द्यायचा आहे सर्किटला, की बाबा हा आउटपुट असं यायला यायचं, बरोबर आहे?
yes, sir.
आणि जर व्होल्टेज घेतला आपण तर ते कसं घेतो? शंट मध्ये. शंट म्हणजे काय?
Parallel.
पॅरलल मध्ये. जर व्होल्टेज असं आलं तर सांगू शकतो की बाबा आपलं आउटपुट व्होल्टेज असं यायला आपल्याला थोडं मॉडिफाय करावं लागणार आहे. जसा फीडबॅक येईल तसा तो आपण काय करतो? मिक्सर मध्ये सर्किट ऍडजस्ट करतो, जो आपल्याला पाहिजे तसा भेटायला पाहिजे, बरोबर आहे?
Yes, sir.
नाव इट इज क्लिअर.
Yes, sir.
If anybody has any doubt, so let me know. Otherwise, we stop here. So I request all of you put the message in chat box, so I can consider from the attendance from that chat box. So, okay, so I consider here is no one has any doubt. So we stop here. Thank you so much. Have a nice day. Don't leave the meeting. I want to cross verify the attendance.